Let us continue ionic equilibrium. In an ionic equilibrium, we have discussed salt hydrolysis. Now we will take a salt ammonium cyanide. We will take a salt ammonium cyanide. Ammonium cyanide aqueous solution we will take. In the ammonium cyanide aqueous solution, what are the ions present in the sense NH4 plus cation and Cn minus cation? Now, in this salt, which will undergo hydrolysis? Cation or anion? That we will see. Now, ammonium ion is from weak base ammonium hydroxide. Therefore, ammonium ion undergoes hydrolysis. Therefore, cationic hydrolysis is possible here. Cyanide is from weak acid hydrogen cyanide. Therefore, cyanide also undergo hydrolysis. Therefore, in this salt, cation as well as anion both undergo hydrolysis, we can say. Now, what is the pH of resultant solution? pH of resultant solution that we can find using the formula concentration of H plus is equal to square root of Kw into Ka by Kb. Using this formula, we can find a concentration of H plus, then we can find pH. Now, ammonium is from ammonium hydroxide, that Kb is 1.8 into 10 power minus 5. Cyanide is from HCN, that Ka is nearly 10 power minus 10. So, here how Ka and Kb is there, you can note. Here we can say Ka is less than Kb. Ka is less than Kb. Okay. Therefore, we can say concentration of H plus is less than square root of Kw. Therefore, we can say concentration of H plus is less than 10 power minus 7 molar at 25 degrees Celsius. Therefore, the resultant solution we can say basic. Okay. Next we will take a ammonium acetate. Ammonium acetate salt solution we will take. In this acetate ion is from weak acid acetic acid that undergoes hydrolysis. That Ka is 1.8 into 10 to the power of minus 5. So Kb value we know, here we know, ammonium we know. So in this case, Ka is equal to Kb. Therefore, we can say concentration of H plus is equal to square root of Kw. Square root of Kw we can say. Therefore, concentration of H plus is equal to 10 power minus 7 molar at 25 degrees Celsius. Therefore, resultant solution is neutral, we can say. Next, we will take some anilinium acetate. Anilinium acetate we will take. Anilinium acetate we have taken. In this salt, this cation is from aniline. That aniline Kb value is nearly 10 to the power of minus 10. Therefore, it is weak base. So, anilinium ion undergo hydrolysis. Acetate also undergo hydrolysis. Here, Ka is greater than Kb. In this case, Ka is 10 power minus 5. Kb is 10 power minus 10. So, Ka is greater than Kb. Therefore, concentration of H plus is greater than square root of Kw. So, we can say concentration of H plus is greater than 10 power minus 7 molar. Therefore, resultant solution is acidic. So, in the salt, if both cation and anion undergo hydrolysis, then the resultant solution is three possibilities are there like this. Three possibilities are there: acidic, neutral, basic, like this. That depends on what, in the sense Ka, Kb we can say. So, what is the conclusion? If Ka is equal to Kb, resultant solution is neutral. If Ka is high, resultant solution is acidic. If Kb is high, resultant solution is basic. Okay. Then in some salts, neither cation nor anion undergo hydrolysis. That aqueous solution is neutral. In some salts, anion alone undergoes hydrolysis. That aqueous solution is basic. In some salts, cation alone undergoes hydrolysis. That aqueous solution is acidic. If both undergo hydrolysis, if both cation and anion undergo hydrolysis, then the resultant solution comes under such a type of category. Okay. We'll go to next topic. Next topic is a buffer solution. Next topic is buffer solution. So, what is buffer solution? That we will see. Now we will consider a blood. Now we will consider blood. For the patients, if you see, saline will be injected. That means injecting glucose like this, they will say. Saline will be injected. Sorry. This saline is injected in the sense it is injected directly to the blood through the nerves. Now, this pH and this pH, if you see how it should be, there means they should be equal, otherwise nearly equal. Then only it can be injected, otherwise no. Sir, that means this pH is nearly equal to this pH. Even after injecting also, this pH and this pH should almost remain same, otherwise equal. Difference should not be there. That means the pH of this solution in this one after injecting remains same as like this. Therefore, this solution is called what, in the sense we can say buffer solution. This solution we can say as a buffer solution. Buffer solution in the sense that solution pH almost remains same, though some external effect is there. That means buffer solution means this solution pH remains almost same. Almost only we are saying, exactly same we are not saying. Almost remains same, though external effect is there. That means if external effect comes, certainly whatever the thing is there, certainly changes. But that change should be to how much extent can be minimized, that much extent should be minimized. Okay. So in that category, this buffer solution comes. Sir, we will see an example for this. Now we will take a NaCl, we will take this 1 mole, we will take. To this we will add water. We will prepare what, in the sense 1 molar aqueous solution of NaCl we will prepare. In this salt, neither cation nor anion undergo hydrolysis. Therefore, this solution is neutral. This solution we can say neutral solution, we can say. Neutral solution in the sense pH is equal to 7 if temperature is 25 degrees Celsius. Okay. Now, to this solution, let us add acid. Let us add acid. How much acid we are adding, in the sense 1 millimole of HCl we will add. 1 millimole of HCl we will add. Volume change will take negligible. So in the resultant solution, HCl will be there. That concentration is this 1 millimole by 1 liter, because this is 1 liter will take. So 1 millimole of HCl we have taken, and 1 liter of HCl in the sense 1000 ml. So we are getting a 10 power minus 3 molar. Concentration of HCl is 10 power minus 3 molar in the resultant solution. Sodium chloride also present in the resultant solution. This HCl undergoes ionization to give H plus ions. H plus ions concentration is 10 power minus 3 molar. Now pH formula we will take pH is equal to minus log of concentration of H plus. Now we will substitute this H plus concentration, then we will get pH 3. Now if we see pH is 3. Now you see this pH. pH is how much in the sense 7 here. To this we added just 1 millimole of HCl. How much pH changes you see? Here 7, here 3. Change is 4. So this much pH changes in the sense, shall we call this is as a buffer solution? We cannot call this is as a buffer solution. How can we call this is as a buffer solution? We can't. Sorry. 1 millimole of HCl means how much weight? That we'll see. 1 mole of HCl in the sense 36.5 gram. 1 millimole of HCl in the sense into 10 power minus 3. Therefore, how much weight of HCl you see it. Therefore, we added a small quantity of, very small quantity of HCl only we added. For that itself, this much change in pH. Suppose if we add 1 mole of HCl, what will happen, that we'll see. 1 mole of HCl in the sense this 36.5 gram we have to add. Okay, so we will add 1 mole of HCl. So if we add 1 mole of HCl, how the pH will be there, that we will see. Okay, 1 mole of HCl we are adding. So HCl we added 1 mole. Here solution volume is 1 liter. That 1 liter we have written. Then here we will write the concentration of HCl is 1 molar. Concentration of HCl is 1 molar in the sense H plus concentration is how much in the sense 1 molar we can take. So 1 molar. Then how the pH will be there, you think it? How the pH of solution will be there? pH of solution will be 1 if you assume activity coefficient is nil. Actually it is not, we should not substitute in this formula. This H plus concentration we should not substitute here. So better we will take 0.1 mole. So we are taking 0.1 mole. Okay, that means here into 10 power minus 1. 3.65 gram only we are adding. Now we will substitute this H plus concentration. We are getting pH is 1. Now how much change you see? How much pH changes? Here pH is 7. Now pH is 1. pH changes 6. That means pH is 1 means strongly acidic. This solution is strongly acidic. That is the mean. How much HCl we added? Just 3.65 gram we are adding for 1 liter solution. Okay. Now, so shall we call this solution as a buffer solution? Buffer solution means what? It has to resist the change in pH on adding acid or base. On adding acid or base, it should resist the change in pH, then the solution is buffer solution. But in this case, we are adding acid. This solution is unable to resist the change in pH. Therefore, this solution is not buffer solution. This solution, we cannot say it is buffer solution. Similarly, if we add base into this solution, pH changes. pH changes. Therefore, we cannot say that this solution is a buffer solution. Therefore, aqueous solution of salt of strong acid and a strong base, we can't call that is as a buffer solution. Sir. Now, opposite of this we will take. Opposite of this. What is that means? Ammonium acetate. Ammonium acetate solution we will take. Ammonium acetate means this salt is from weak acid and weak base. Okay, this salt, it is a salt of weak acid and weak base. But in this case, we have taken salt of strong acid and strong base. So salt of strong acid and strong base aqueous solution is not a buffer solution, that we concluded. Now we have taken opposite of this, exactly opposite of this. What is that mean? Salt of weak acid and weak base. Now do this. If you do like this, what happen means Here also pH changes, but pH changes to very small extent, very small extent. But here pH changes drastically. Here pH changes drastically. Here pH changes to very small extent. Then we can call this is as a buffer solution. So buffer solution means, what is the definition? It has to resist the change in pH. So now if you see, we are adding acid, pH changes drastically. We are adding acid into this, pH changes to very small extent. Therefore, this is not buffer solution. It is also not buffer solution. Because what is the definition of buffer solution? It has to resist the change in pH on adding acid or base or water. Whatever you add into this pH should not change. Then only it is called buffer solution. If the pH is not at all changing on adding small amount of acid or base or water or anything, then it is a perfect buffer. But perfect buffer is not possible. So this nearly acting as buffer. Nearly acting as buffer in the sense we can say example. Nearly acting as buffer solution means example is there. That is, one example is this one. Salt of weak acid and weak base. This solution pH changes nearly. That means this pH changes to very small extent. Therefore, this solution is acting as a buffer solution, almost buffer solution we can say. So, now one example we have taken, salt of strong acid and strong base. It is not buffer solution we said. Next example we have taken, salt of weak acid and weak base. This is buffer solution we said. Is there any other example for this? Other types of salts, shall we take? Other types of salts in the sense, one we said strong acid plus strong base salt. Next, weak acid plus weak base salt we said. What is the other type of salt? Other type of salt in the sense, we can say weak acid plus strong base. That salt we will take. That salt we have take. To that this weak acid some amount we have to add. Then this mixture act as a buffer solution. Buffer solution means nearly acting as a buffer solution. Then we will take another type of salt. Another type of salt is what? Strong acid plus weak base. This salt we will take. To this salt we have to add this weak base, some amount we have to add. This mixture is acting as a buffer solution. So which and all acting as a buffer solution means, one we said salt of weak acid and weak base, it is one buffer solution. Next, salt of weak base and strong acid plus the same weak base. Next one, salt of weak acid and strong base plus the same weak acid. These three acting as a buffer solution. Now we will see the example for buffer solutions. We will see. Okay, so now we have to say what in the sense. First, weak acid plus strong base, that we will take. Weak acid plus strong base, that gives salt, plus this weak acid some amount, this weak acid also present. That means weak acid some extra should present. Extra means how much? How much proportion? These two may be equal proportion, or one is less, or another one is high. Certain condition is there. As per that, the proportion should be there. Okay. So now we are taking this. Weak acid, example acetic acid. Strong base, example sodium hydroxide. Now both are reacting to give what in the sense? Salt and water. So now you take this salt, you take this salt. Okay, we have taken this salt. And you have to add weak acid, same weak acid you have to add. That acetic acid you take and mix. Now we can say this mixture is a buffer solution. This mixture is a buffer solution, we can say. So now I will take weak acid is what in the sense? H3PO4. Okay. Weak acid H3PO4 we have taken. Now base is same sodium hydroxide, let it be. What is the salt in the sense? Suppose NaH2PO4. NaH2PO4. So now I will take this salt NaH2PO4 I will take. To this salt what we have to do? We have to add weak acid. Which weak acid? Same this weak acid we have to add. How much? That depending on the preparation. Depending on the preparation means in what way you want to prepare, in which proportion you want to take, in which proportion you want to take these two. In that manner we have to take. Which proportion we have to take? Allowed is what in the sense? 1:10. Otherwise 10:1. Otherwise in this range. In this range. It is allowed. So in this range, which ratio you want to take, that ratio we have to take. Okay, sir. Now we said buffer solution example, sir. Next, another example we'll see for this buffer solution. Another example we are going. Now we will take this NaH2PO4. This NaH2PO4 contains H plus ions. It can donate H plus ion. It can react with the strong base sodium hydroxide. Therefore, we can say this is acidic salt. Why you are calling this as acidic salt? Because this salt can react with sodium hydroxide to give us another salt. That another salt we will see Na2HPO4 plus water. So this salt is able to react with another molecule of sodium hydroxide. Therefore, this salt is having acidic hydrogen. This salt is able to give H plus ion. Therefore, we can call this as acidic salt. Okay. Now, what is the acidic strength of this salt when compared to this weak acid? This weak acid acidic strength is high. This weak acid acidic strength is low. If you go on replace H plus, acidic strength goes on decreases. Okay, sir. Now this acidic strength is less than this one. This one we can say. Sir, anyhow we got a salt. We will take this salt. Okay, we have taken this salt. To this salt, let us add weak acid. Which weak acid? It is from which weak acid? That weak acid we have taken. This salt is from which weak acid? This weak acid. Okay. This salt is from this weak acid. Therefore, this weak acid you take. Okay. Now, how these two should be there means between these two, one H plus should be different. Okay. One H plus is different. Like this, here also we have taken. This is also buffer. This is also buffer. Next, I will take this salt. Na2HPO4 I will take. Now I am taking a Na2HPO4 I am taking. To this, let me add sodium hydroxide. What happens means a reaction takes place and I am getting Na3PO4 salt and water. So now I will take this salt, Na3PO4 I will take. To this I will add weak acid. We prepared this from which weak acid? That weak acid you take and add. Which weak acid? From which weak acid we have prepared this? From this weak acid we have prepared. So take this weak acid and mix Na2HPO4. Now this mixture is an example for a buffer solution. Okay. Now we have discussed like this buffer solutions we have discussed. These buffer solutions are prepared by taking weak acid and its salt of strong base. Therefore, these are called acidic buffers. These are called acidic buffers. Now, if you take instead of weak acid, if you take weak base, then that is called basic buffer we can say. Okay, so now we will take that. Okay, now we will take weak base. Weak base is what in the sense, for example, ammonium hydroxide. Then we will take strong acid. Strong acid example is HCl. Now they are reacting to give a salt, ammonium chloride and water. Now let us take this salt, NH4Cl salt we have taken. To this, what you have to add? This is prepared from which weak base? That weak base you add it. This is prepared from which weak base? This ammonium hydroxide weak base. That ammonium hydroxide you take and mix with this salt. This mixture is called buffer solution, basic buffer also you can say. Sir, now we will take another weak base. Suppose we are taking a weak basis aniline. We are taking weak basis aniline we will take. To this weak base, let us add sulfuric acid. Sulfuric acid. What we will get? That we will see. Now this nitrogen takes H plus. This is a donating lone pair to this. Sorry, how it is donating, that we will see. So aniline we will write like this. It is having lone pair. The sulfuric acid, in that sulfur is there. 4 oxygen atoms are there. 4 oxygen atoms. Sulfuric acid is called oxy acid. Oxy acid means it will have hydroxy group, OH group, that will donate H plus. Therefore, it is acid. Okay. Hydroxy group means don't think that that is base. Huh? Not only base, this oxy acid also comes under that case. This contains OH group. It will give H plus on dissolving in water, but not OH minus. Okay. Therefore, here 2 hydrogens are there. That 2 hydrogens we will write with oxygens. Hydrogen will make one bond always. Oxygen will make 2 bonds. That means one is a double bond, otherwise 2 single bonds. 2 single bonds. Or we can write a double bond. We can write like this. Now, how the shift takes place, you see, nitrogen donates lone pair to this hydrogen. This bond pair will be shifted to oxygen. Okay, this bond pair will be shifted to oxygen, we can write. Now we can write this phenyl ring, this N, this hydrogen, this lone pair is making dative bond with hydrogen. Why dative bond? This is contributing lone pair, it is contributing vacant orbital. This bond is shifting to oxygen, okay. So we will write like this. We have written like this. This oxygen is gaining this bond, therefore this oxygen is getting negative charge. This hydrogen is losing this bond, so this hydrogen is getting positive charge. Okay, so this is the salt. In this salt, let us make this dative bond as normal covalent bond. This dative bond we will rub. We will write normal covalent bond. Then you have to give formal charges. You have to give formal charges in the sense this nitrogen is a donor. For donor, you have to give formal charge +1. Hydrogen is acceptor. For hydrogen, acceptor means you give -1. Already +1 is there, you are giving -1 is there, means net charge becomes 0. Therefore, don't write any charge. It is the salt, anilinium bisulfate, we can say. Okay, sir. Now, aniline reacts with sulfuric acid to give the salt. That salt will take. The salt is what in the sense this anilinium bisulfate, we can say anilinium bisulfate. Now we will take this anilinium bisulfate salt. We will take this anilinium bisulfate salt we have taken. To this salt, what we have to add means it is prepared from which weak base? That weak base we have take. Weak base is aniline, so add aniline weak base. Okay. Now we can call this mixture is a buffer solution. We can call. Sir, so what is the here this buffer solution is basic buffer we can call. Sir, what are the buffer solutions we have discussed? You see that one is a salt of weak acid and strong base plus the same weak acid. It is one example for buffer solution. Another one is weak base plus salt of its strong acid. This is one buffer solution. Another buffer solution is salt of weak acid and weak base. It is a buffer solution. Okay. Now I will give one substance. I will give. You have to say that whether that substance is a buffer solution or not. Okay, sir. You are given what is the substance in the sense CH3 NH3 plus Cn minus. this aqueous solution is given. Now you say whether it is a buffer solution or not. CH3 NH3 plus Cn minus aqueous solution is given. Whether it is buffer solution or not, you say it. Now I will say some more details about this. Some more details about this I will say. Okay. Now I will take CH3 NH2. CH3 NH2 I am taking, nitrogen is having lone pair. This CH3 NH2 is called methylamine. This name is called methylamine. I have taken. Then I will take hydrogen cyanide. Hydrogen cyanide. Hydrogen cyanide. HCN. Hydrogen cyanide I have taken. Now, this is here how the reaction takes place, that we will see on mixing these two. Nitrogen is donating lone pair to this hydrogen. This bond is shifting to this carbon. Therefore, what is produced you will see. Now, this CH3 will take this NH2. This NH2 here lone pair is making dative bond with hydrogen. Then this Cn. This Cn, this bond is shifting to carbon. Therefore, carbon is having lone pair. This carbon gaining the bond. Therefore, carbon is gaining the electron. Therefore, getting negative charge. Hydrogen is losing the bond. Therefore, getting positive charge. Sir, next let us shift this dative bond. This dative bond we will write it as normal covalent bond. Then we will give formal charges. What is the formal charge means? Nitrogen is donor, therefore +1. Hydrogen is acceptor, therefore -1. Net charge is how much means 0. Sir, we got this. For this methylamine, Kb is nearly 10 to the power of -10. Therefore, this methylamine is a weak base. Weak base. HCN Ka is nearly 10 power -10. Therefore, this HCN is a weak acid. This weak base reacts with weak acid to give this salt. This salt solution only we have written here. Now you say that this salt solution, shall we say this salt solution, it is a salt of weak acid and weak base. Therefore, shall we say it is a buffer solution? Yes, it is a buffer solution, we can say. Sir. Next, I will give one example. Whether that is a buffer solution or not, you say. Now we will take KHS plus H2S. KHS plus H2S aqueous solution. Okay. So what is aqueous solution? This aqueous solution contains KHS and H2S. Now this mixture, this aqueous solution, is it a buffer or not? What do you say? Okay. Something about this solution we will discuss. Now I will take H2S gas. H2S gas. This gas, if you pass into water, it will dissolve in water. Therefore, we can write H2S aqueous. We can write H2S gas. If you pass into water, it will dissolve. This H2S we can use in the lab for salt analysis. This H2S gas smell is a rotten egg smell. If egg is spoiled, then if egg is rotten, if it is spoiled, what bad smell we will get? That bad smell this H2S will have. Like that bad smell it will have. Okay, sir, H2S aqueous solution we have taken. To this, let us add potassium hydroxide solution. Potassium hydroxide solution we are adding. What we are getting, we will see. This H2S, I will write H plus, HS minus, I will write. HS minus aqueous, H plus aqueous, I will write. This H plus and this OH minus becomes water. This K plus and HS minus becomes what in the sense K plus HS minus aqueous solution. So we got here salt solution we got. What is the salt solution? KHS. KHS salt solution. And this H2S we will take H2S. Now you see, for this H2S, what is the Ka value? We will see. Ka1 equal to 10 power minus 7. Ka1 means because it is having 2 H plus ions. Therefore, 2 H plus ions it is having means 2 Ka values we have to say. That Ka values also I will write first. Now H2S. First it will give 1 H plus. Then it will become what in the sense HS minus aqueous. For this Ka is called Ka1 is nearly 10 power minus 7. Then This HS minus aqueous dissociates to give H plus and S2 minus aqueous. For this Ka2 we have to say nearly 10 power minus 14. So H2S means it is having two replaceable H plus ions, therefore two Ka values will be there. Suppose now we will take one acid H3PO4. It is having three replaceable H plus ions. So how many Ka values will be there? Three Ka values will be there. Ka1, Ka2, Ka3. Okay, sir. Now this H2S is having Ka1 and Ka2 is 10 power minus 14. So this Ka value is very small. Therefore H2S we can say weak acid. You know potassium hydroxide is a strong base like sodium hydroxide. So weak acid plus strong base gives salt. Here salt is formed. Therefore we can say it is a salt of weak acid and strong base. This KHS we can say salt of weak acid and strong base plus its weak acid, what? H2S. Therefore this aqueous solution, this solution we can call it as a buffer solution. Shall we say? Yes. So it is a buffer solution we can say, sir. Now I will take some other example I will give whether this mixture is this solution is a buffer solution or not, you say. Okay, I will take what in the sense rubidium bicarbonate plus rubidium carbonate. This aqueous solution I have given. This aqueous solution, do you say it is buffer solution or what? Okay, let us check whether it is a buffer solution or not. We will check. We'll take what in the sense H2CO3. This H2CO3 is dissociating to give what in the sense H plus and HCO3 minus. For this we can say Ka1. This Ka1 value is less than 10 power minus 3. Therefore we can say it is weak acid. This HCO3 minus on further dissociation gives H plus and CO3 2 minus. For this we can say Ka2. Ka2 always less than Ka1 for the same substance. We should not compare with different substances. That means this Ka2 comparing with this Ka1, like this we should not do. This Ka2 we have to compare with this Ka1 only. Now we can say this Ka2 is smaller than this Ka1. Like this only will be there. Even you see this Ka2, you see that is smaller than this Ka1. Like this only will be there. Okay. Now we can say that this HCO3 minus is a acid. Therefore we can call this is acidic salt. Okay, this acidic salt, this is acidic salt. Okay, that means it is having acid. This acidic salt. Okay, what about this? So how to get this acidic salt, that we will see first. Now we will take a H2CO3. To this we will add rubidium hydroxide. Rubidium comes under first group, alkali metals. Alkali metals means lithium, sodium, potassium, rubidium, cesium, alkali metals. Okay. Now what is the salt we are getting in the sense rubidium bicarbonate we are getting plus water. It is a salt. Okay. This salt will take, this is weak acid here, it is strong base. Therefore we can say it is a salt of weak acid and strong base. This rubidium bicarbonate will take. To this we will add strong base rubidium hydroxide. We are getting a salt Rb2CO3. Salt we are getting. Now this is a salt. This salt, it is strong base. It is a acidic salt we can say because it is reacting with the base. Therefore it is acidic salt. This acidic nature comes under weak acid category. Therefore this salt plus its acid